So in this video, I'd like to go over the answers to this worksheet where we are talking about balancing nuclear reactions. And I want to point out that even though it asks for several of these types of emissions, the only reactions that you're going to be responsible for are alpha decay, beta decay, fusion, and fission. All right, so if it's outside of one of those, I'm just going to go ahead and tell you that you can skip it for now. So, and actually, we're not going to be going into those. If you were to take some later chemistry course where they talk more about these different types of nuclear reactions, you might be responsible for those. But this is designed to be an introduction to nuclear reactions. Okay, so in the first problem right here, again, with all of these nuclear reactions, it's all about making sure that the atomic numbers add up on both sides and that the mass numbers add up on both sides. All right, so on the right side, all right, so I just brought this down here. We've got a grand total of 19 on the left side of the equation because there's only one thing on that side, right? But on the other side, we've got this thing, but plus something else. So the way that you can think about it is what number plus a -1 would give you 19? All right, and you could set it up algebraically if you wanted to, like this, just figure out what x is. All right, well, 20 plus a -1 equals 19. So that tells you what the bottom number right here is. All right. At the top, 42 is what you have on the left side. So 0 plus what gives you 42? That's going to be 42. All right, and to figure out what the element is, we know it's got an atomic number of 20. So we can look at the periodic table and figure out that that would be calcium. All right, so that's the missing particle right here, or the missing part of this. And since this is something where you're ejecting this electron, all right, that's when you're having beta decay. All right, so that right there is the hallmark of beta decay. All right, in this particular example right here, we can already tell that this is going to be alpha decay. It's something where you've got a large element and it's spitting out this helium particle, so that's alpha decay. But let's figure out what that missing piece is right there. Okay, so 2 plus what would give you 94? All right, so you should be able to figure out that would be 92. All right, and at the top, all right, 4 plus something should give you 239. All right, that's going to be 235, and that would be uranium because the atomic number is 92. All right, I'm going to go a little quicker through these again. Try to add up the stuff on the left and the right. The part that would be missing here is a helium atom, and that would mean it's alpha decay. All right, in this case right here, the sum on the bottom is 2. At the top, it's 4. That's a helium atom. All right, and here, this is a fusion, an example of fusion. Remember, you're not taking something and spitting out helium plus something else. You're just taking these two things, putting them together to make helium. All right. Number 5, all right, you have more than one thing. So I'm going to add up the total of things of the atomic numbers on the left and the total of the mass numbers on the left, and then try to figure out what's missing. All right, so 2 plus 1 gives me that total of 3. All right, 4 plus 3 gives me that total of 7. All right, so I can figure out that this is the particle right here. This is actually, the name of this is called tritium. All right, it's something that's used in nuclear, has a lot of uses in nuclear reactions. But as far as like getting this to fit into one of those types of reactions, it doesn't really fit neatly. So I'm just going to tell you to skip that classification. All right, but you should be able to figure out that this would be the particle. All right, moving on. All right, in this problem right here, you should be able to figure out that the missing, so you have a total of 15 down at the bottom, so that would be 0. You have a total of 31 at the top, so that would be 1. And the particle that has a 0 atomic number with a mass number of 1 is a neutron, which you represent as just a lowercase n. All right, and again, skip that classification. All right, so these follow that same basic pattern. You should be able to figure out that this had to be a 3 down here and that this had to be a 6 up here. That makes that lithium. You say that's lithium 6. All right. Number 8 right here. All right, we're going to skip this. This is actually has to do with this thing called a positron emission. You're not responsible for that, but notice that's what this is right here. In case you've, in medicine, there's these things called a PET scan, a PET scan, and that stands for positron emission. I forget what the T stands for, but this little particle right here is used in that type of in that technology. All right, so this one right here, add up all of the numbers down at the bottom left, and notice that there are 3 of these things right here. All right, so the grand total of the atomic numbers is 92. The grand total of the mass numbers is 236. And remember, you've got 3 of this thing. So since there's 3 of these things that have 1s right here, that would give you a 3. So that's how you come up with that 236. All right, and then find the part that's missing. All right, that's going to be uranium right here. And this is that example, that classic example of a fission reaction, where you've got a large atom which is splitting apart into 2 comparably sized atoms. All right, on this example right here, we have 94 on the left side, so that you can figure out this is plutonium right here. And in terms of classifying this one, I'm going to say that this is possibly a fusion reaction, although I don't hold me to that. You would not be responsible for this particular reaction on any type of assessment in here. But you should be able to figure out what that missing particle is right there. Okay, here, what number plus 7 gives 6? That's a -1. What number plus 14 gives 14? That's a 0. So this is the piece that is missing in the type where you're ejecting this electron is beta decay. All right, in this case right here, we can figure out that is a hydrogen atom. All right, and this is not one of the examples that we have learned, so we'll skip that. Hello? All right, and this right here, we have sodium. We add, what number plus 11 gives 10? That's a -1. What number would be required up here? That's a 0. So this is an electron. In this particular, it looks like this sodium atom is capturing an electron. All right, but we don't have a name for that type of reaction, so you can skip the classification of that. This last one right here, we can figure out that the number at the bottom would be 101. The number at the top would be 256, and therefore this doesn't fall under any of those classifications. All right, so so the next few problems, it says write the balanced nuclear reaction for the alpha decay of these elements right here. So remember, alpha decay is when it spits out a helium atom. All right, so let's start by writing down the symbol for plutonium 234. We know that since it's alpha decay, it spits out this particle right here. All right, and then we just have to figure out what is left. All right, so that would be this uranium atom right here. All right, same thing with strontium. We are taking this right here, that we're spitting out a helium atom. And in this case right here, again, we're spitting out a helium atom. So you need to figure out what particle is 2 less than 38. That's 36. That means that that is krypton, and it would have this mass number. All right, in this problem right here, I'm only going to hold you responsible for alpha and beta decay. All right, so the first problem is just like the ones that we were doing in the problem before. You can figure out that that is radon. All right, and in this problem right here, beta decay is the loss of an electron. So this is the symbol for an electron right there, and just figure out what these numbers would have to be. And you can figure out that this would be the missing particle.